Okay, this is target 7 from Unit 7, finding the distance from a point to a line. You can pause the video if you need to read through this more on your own. It says finding the distance from a point to a line. The distance from the point to the line is the length of the perpendicular segment from the point to the line. The reason for that is because that gives you the shortest segment. If I use this diagram here, if I draw A and I connect to the line any other way, all of these lines are going to be larger than the line that's already drawn perpendicular. So the key for target 7 is understanding that anytime you're trying to find the distance between a point and a line, you have to measure it as a perpendicular distance. So it doesn't matter if we have this line drawn here or if I draw any type of line at a diagonal like that. If I'm trying to find the distance from a point to that line, we need to make sure that we're doing it as a perpendicular line segment. So if that's my point and that's my line, I want to try to go as close as I can to being a perpendicular line segment. That's the point of the target. So here's a couple of examples. This one says find the distance from the point 5, 3 to the line y equals negative 2x plus 3. Well, if I want a perpendicular line segment, that means I need to find the slope of the line that I'm working with. So this slope is equal to negative 2, or we could say negative 2 over 1. My perpendicular slope would be the opposite reciprocal. So it's going to be positive, and the reciprocal of 2 over 1 is 1 over 2. So you have to find your perpendicular slope, which is the opposite reciprocal. So if I start at my point, 5, 3, I need to draw a line that has a slope of 1/2. So usually we would go up 1 over 2 a couple times. You could go down 1 and left 2. And I don't need to draw the entire line. I really just need to draw the line segment. So if I draw the line segment with that slope of 1/2, I can see it intersects at the point 1, 1. And now you're doing what you did earlier in the unit. You're trying to find the distance between 1, 1 and 5, 3. So you could use the distance formula, or you could create a right triangle and do the Pythagorean theorem. So if I went up 2 and over 4, and I call this distance c, then I can do the Pythagorean theorem. 2 squared plus 4 squared is equal to c squared. So 4 plus 16 is equal to c squared. So 20 is equal to c squared. The square root of 20 is equal to c. And then we can also simplify that to square root of 4 times square root of 5. And that simplifies to 2 root 5. So that's the distance from the point 5, 3 to the line, 2 root 5, or square root of 20, which is going to be between 4 and 5, so 4 point something units. Second example, y equals 2/3 x plus 5 to the point 7, 1. Again, we start by finding the slope of the line that we have graphed, which is equal to 2/3. Then our perpendicular slope is going to be the opposite, so negative instead of positive, and 3 over 2 instead of 2 over 3. So if I start at my point and I do a slope of negative 3/2, I'll go to here, and then I'm kind of out of space. So instead of down 3 and right 2, I can go up 3 and left 2. And that would be my slope if I drew that line through all the red points with a negative 3/2. I only need to draw the line segment. And it does intersect nicely. That's the point 3, 7. And so now I'm finding the distance between the point 3, 7 and the point 7, 1, which you can use the distance formula, or you can create a right triangle. We always do our right triangle just by following the grid. So this is 4 units over and 1, 2, 3, 4, 5, 6 units down. We can call this C if we want to use the Pythagorean theorem. You can call it D if you're doing the distance. 4 squared plus 6 squared is equal to C squared. So that's 16 plus 36 is equal to C squared. 16 plus 36 is 52. So C is equal to square root 52, which simplifies. 52 is 4 times 13, so 2 root 13.